Alright, welcome ladies and gentlemen to a quick tutorial. I'm going to go through some of the problems on the wave and energy equation practice sheet. This is number 5 from that sheet, and I will have to make a couple adjustments because my conversion over from Google Doc didn't include my exponents. So this number here should be 1 times 10 to the 9th nanometers per meter, and we're going to use that in our conversion. So first, if I have a wavelength emitted of 518 nanometers, and I'm going to do some calculations with my speed of light, I have to get to meters because that is the unit on the constant. So I'm going to take my 518 nanometers, and I'm going to multiply that times my conversion factor. I want to get to meters, so I'm going to put that on top, and then my 1 times 10 to the 9th nanometers goes on the bottom, so that when I cancel out my unit, I have 1 on top, 1 on bottom, and my answer will be in meters. That will give me 5.18 times 10 to the negative 7th meters. Now I need that because if I'm going to calculate frequency in part B, my equation is C equals lambda f, and lambda is my wavelength, so that's the part that I know. If I want to get frequency by itself, I'm going to divide both sides by lambda. So then in this equation I need C over lambda equals frequency. So C is the speed of light. That's going to be 3 times 10 to the 8th meters per second divided by 5.18 times 10 to the negative 7th meters. So the reason we needed meters is that I need my units to match when I do my calculation. When you solve that answer, you will get 5.79 times 10 to the 14th, and my unit is hertz. Remember, that is equal to 1 per second, and if we look here, when the meters cancels out, that would equal 1 per second is my unit. Now, the next question says, what would that energy be in joules? In this case, we are going to have to use the equation E equals HF. In this case, I know my frequency from here. So this is going to be equal to Planck's constant, which is 6.6262 times 10 to the negative 34th joule seconds. And I'm going to multiply that times my frequency. And that is a 10 here. Okay, and that makes this 14. When I solve that equation, I should arrive at the result of 3.84 times 10 to the negative 19th joules. Now, I've added a visible spectrum to help us decide what color this wavelength would be. Now, the best help for us is going to be to look to the original wavelength we were given as 518 nanometers. We take a look here. 518 would probably fall in this range or so. So we could say that it is a kind of blue-green color based on the wavelength that is here. So things to point out. First of all, to convert, we had to convert to meters because that is the unit in our constant with our speed of light. C equals lambda f. When we rearrange to solve for frequency, it's going to be speed of light divided by the wavelength. If we want to calculate energy using E equals HF, we needed our frequency from the last calculation, and H is Planck's constant, which is the 6.6262 times 10 to the negative 4th joule seconds. And we can connect all of those together. The color is related to the energy, the wavelength, and the frequency.